mentioned, we have over 85 years of in-house polymer manufacturing experience. And he also mentioned that most of the competition outsourced some part of their process, which is why we are considered the true market leaders in this technology. And John and the team have continuously worked to improve the formulations to provide a superior product to the market. And you as our customers play a huge, important part in our developments. And we'd like to thank you because based on your feedback, we've been able to understand in better detail what the requirements the customers have as the end users. And with this feedback, what we've managed to do is work with John and the team and come up with a new diaphragm, the new chlorine or KC diaphragm, which we'll go in a bit more detail as we go through the presentation. But it's a big thanks to you guys to inform us of this requirement in the marketplace. So it's an exciting diaphragm to bring out and hopefully address some of the key issues that customers, may be having. So some of the changes that we've made are to refresh the naming of the range. Again, we'll go through in a little bit more detail further into the presentation. But if we look at the one-piece diaphragms, the elastomer diaphragms, they are now called the Extreme Elastomer range. So what we've done is we've taken the letter X out of extreme, and that is what is the first letter of the grade of diaphragm that you would be ordering. The second letter denotes what grade or application of diaphragm it is. So just to take an example, if we were talking about an extreme EPDM diaphragm, the code for this would be XE. So we're trying to make this as simple as possible. Then you come to the PTFE facing diaphragms. And these have been given the name high performance PTFE. So all of these diaphragms would start with the letter P. And again, the second letter would denote which grade of the backing material is or the application. And finally, we have a three-layer diaphragm or two three-layer diaphragms. And these start with the letter K, and that's to denote the PVDF interlayer that we've added to aid in permeation resistance. So this change has allowed it to make it easier for you in terms of reordering the diaphragms, and there's no confusion what grade is linked to what name. It's very clear going forward which diaphragm is which. And what we've tried to do as well is make the diaphragms a little bit more application focused. So if we take the example of what used to be a Viton diaphragm, it's a trade name, 226, we're now calling this the extreme chemical diaphragm because this diaphragm performs at higher temperatures and is mainly used in chemical applications. So this will make it a lot easier going forward for you to select which diaphragm you require in the chemical applications. As well as this, we have introduced a new bag design, and there's some huge changes in terms of the bag design and a lot of benefits coming with it, which we'll go through further in the presentation. And just to support you further, we've also created a high quality set of rendered images for the entire range. So if you want to, showcase these diaphragms to your customers without having the physical piece in front of you, then we can provide these images to yourselves to share on your website or to share with the customers. As well as this, we've refreshed the technical data sheets, and we have now a comprehensive brochure giving a lot of key technical information regarding the diaphragms. So the data sheet includes pressure and temperature relationship graphs, some of the key applications that they are best used in, the materials of construction, how to create the code or how to put together the code to reorder your diaphragm, and also some frequently asked questions such as how to install your diaphragm, what the fitment of the diaphragms are. And we believe with all of these changes that we've been able to make, we have truly differentiated ourselves from the competition in a positive way.
Okay, so as a diaphragm, as Roy had said, it's the heart of the valve, and it's the piece that works probably the hardest of all the components. The body, the top works, and the diaphragm. That is the main piece that ultimately, if it's not there, the valve doesn't function properly. So it's my job and the job of my team to create formulations and create rubber or polymeric components that have multiple properties in order to meet the demands of the industry. And this here is kind of a hierarchy of importance, if you like, for those said polymers. Now, of course, the diaphragm has to have a high flex life. It has to not fail prematurely in service, and ultimately, all diaphragms invert from open to closed at some point in their life. Some of those products will invert open to closed many times a day, many times an hour even, but other diaphragms may stay closed for days or weeks on end because they're being used to isolate particular parts of a system. So we have to be prepared for every eventuality, hence why we have to make sure that the diaphragm has a very good fatigue life to prevent, as I said, failure in service occurring. The second most important property would be compression set. Now, this is a natural phenomenon that all polymers go through, and it is based around the relaxation of molecular chains. What happens with diaphragms and any polymer is that if you load a rubber, so if you deform it in your hand, it'll bounce back into shape. So it's got this memory function. It can always regain its original shape. But if you held that diaphragm or that piece of rubber in a shape for a long period of time, what can occur is that the rubber takes on a new memory. It remembers that new shape, and when you release your load, it doesn't bounce back to the original shape that it was. So how is that important to a diaphragm? Well, when you have a valve assembly, you kind of have a sandwich of rubber or polymer between two metal faces. You've got the weir flange of the body and the bonnet flange of the actuator or the manual bonnet. And we're compressing that rubber together. We're pulling those two parts together by the fastenings to create a peripheral seal. And it's important that that rubber doesn't relax in that condition, because if it starts to relax, you'll end up with a situation whereby you have leakage to atmosphere. Your line media starts to exhaust through the sides of the valve, and it can cause jets of media shooting out, and that can be a real safety concern for customers. So we have to make sure that that property is really maximized, and we limit the effects of this happening. Now, because it naturally occurs, we can't eliminate it completely, as much as we try. And that doesn't mean that diaphragm valves are fit and forget or they are maintenance free by any stretch. But by limiting that property, we do limit the risk of leakage to atmosphere happening. And then comes into play more of the functional requirements of the diaphragm valve in terms of chemical resistance and abrasion resistance. And that really is a function of line media, process conditions, etc. Chemical compatibility is largely a function of the chemical makeup of the rubber, of the elastomer, the polymer. And that is predominantly necessary because we don't want these things to fall apart in service. If you're using something on a very concentrated hydrochloric acid, for example, we don't want your diaphragm to essentially fall apart and cause problems in the system or cause a safety concern. And the same goes for abrasion resistance. Of course, these diaphragms are used on many applications that involve solid contents. We have the KB diaphragm, especially for high viscosity and slurry type applications. And again, we don't want to have a situation where the rubber is eroded away because of solid content. We want to try to limit that from happening. So we have to try to make a compound that is very good at resisting abrasion. Heat stability is something that is a function of temperature. We don't want the polymer chains to break down or revert, is the technical term for that, under temperature. So we want these things to stay as a diaphragm and not go back to some soft, gloopy sort of state in service. And then we have the approvals and traceability. Now, the approvals are varying by country and varying by application. It could be for water applications. In the UK, we use RAS. In the Netherlands, it's Kiwa. In Germany, it's BFR, etc. If it's food and beverage related, it tends to be EC 1935 in the UK, or in Europe, I should say. And in other parts of the world, whether that's North America, South America, that will change accordingly with geographical location. Traceability is important, and that's one thing we have in abundance over competition, because, as I say, we make these products from literally powder right the way through to a finished diaphragm. So we have good traceability back through the system of all raw ingredients. Now, that's important for us. If we have a failure in service, we like to see when the part was manufactured. We can then address our records, check it was produced correctly with the correct ingredients, etc., etc., just to rule out any sort of potential issues that may occur at the manufacturing stage. And then there's a design feature that's not really a property per se, but it's certainly part of the diaphragm, and a very important aspect of it is how the parts attach to the valve. Now, rubber diaphragms consist of a screw thread attachment, and PTFE diaphragms consist of a bayonet attachment. And the bayonet attachment really is there to prevent point loading of the attachment stud. It prevents any closure force being translated directly to the PTFE face, which is much harder than a rubber component due to the nature of it being a plastic. So again, we want to try to limit a failure in service occurring because of point loading. And why that's important to the customer is that if you have a fitter or a maintenance technician in the field working on a valve, it prevents him from putting, say, for example, a rubber diaphragm into a PTFE diaphragm valve, which would then see very concentrated acids, which would ultimately not be suitable for service for a rubber product, but is suitable for PTFE. So it's a safety aspect as well. It prevents people putting incorrect products into the incorrect valves or in incorrect locations. Next slide, please, Ro. So in terms of the features of a diaphragm, I'm sure you're all familiar with the products, and you've probably seen this slide before in training that I may have given to you. Ultimately, the diaphragm contains some quite important information, namely on the tab, it has the week and year of manufacture. It's important that the diaphragm tab faces the body, faces towards you when you have it in your hand, as that allows us to see the week on the left-hand side, the year on the right-hand side. The diaphragm also contains the grade of diaphragm. Okay, that's on the other side of the tab. So that would say, for example, XE, XB, PC, or whatever that grade may be now. And it contains also the size, country of origin, manufacturer, etc., etc. The reason that this slide has an asterisk next to the size is because that location can move around on the product. It depends on the size, the physical size of the diaphragm as to where that's located. Particularly on the circular form diaphragms, so the size is DM100 and larger. Size and manufacturer tends to be written on the periphery, the edge of the diaphragm, whereas on the square form diaphragms, so your DN8s up to, say DM15s up to DN80, that tends to be on the back of the product. And it doesn't matter where it's located, it's still there, and it still gives the customer confidence that this is a genuine Saunders product, made in the UK and made by us in Saunders. Now on the wetted face, of course, you have the two sealing beads, the peripheral bead that seals to atmosphere around the outside edge, and the center sealing bead that runs across the middle, and that's what closes off downstream pressure by sealing against the weir in the corresponding valve body. Next slide, please, Ro. So here we have the start of this new elastomer range, the extreme range. Okay, I should add a caveat to that the C grade, HT grade, and all the other grades, QAA, etc., are still available. We haven't discontinued those products, but these are the first 4 diaphragms that fall into this new bracket of branding. So the first of that is XE and XB. They're both hydrocarbon-based polymers. In the case of EPDM, this has been changed recently to improve the compression set properties, just to give some added benefit to the end users. Typical applications of that would be fertilizers, water treatments, potable waters. and that's replacing the XA and the former 425 diaphragms. The major change here would be EPDM is curable by sulfur and by peroxide, but we only cure by peroxide, which is a much more expensive curing method, but it gives added thermal stability. So you're not relying upon a carbon-sulfur bond, you're relying upon the carbon-hydrogen bond, which has a greater dissociation temperature and energy, so the chances of failure at temperature are higher. So are lower because of the higher dissociation energies. So we have a much improved product in that area. The XB diaphragm, the butyl diaphragm, again hydrocarbon based, and it probably has very similar properties to EPDM. Great for titanium dioxide, good for potable water and brines. It's also very good at sealing off against gases. And it's kind of more of a legacy product. EPDM does predominantly all the things that butyl does, but historically what happened was butyl was developed around the 1937, something like that, and EPDM was developed in the 60s. So Saunders, been around since the 1930s, obviously offered butyl for much, much longer than it's offered EPDM, and for reasons of legacy and history, we still offer this product in the marketplace for customers who have always used butyl products. Incidentally, in the 1980s, Saunders was probably, it was in the top 5 users of butyl rubber in the industry outside of tire manufacturers. So we were a very heavy user of this material type up until relatively recently. So it's something we can't just discontinue from the portfolio, and we continue to offer it under the new brand XB. And then we move across to the 2 lower diaphragms here, the XC and the XF, and these are more specialty polymers. They're not as common in competition portfolios, probably due to expense. They're more expensive as a raw polymer than the EPDM and butyls, but they have major advantages for certain applications over the 2 other rubber types. So XC is a 226 replacement product. It's a Viton or FKM rubber type. So it's based on a fluoropolymer, and it essentially has almost all the properties of PTFE, but in a rubber, in an elastomer product. So it's very, very good at high temperatures, very, very good at withstanding chemical resistance, and that's all, again, due to its chemical construction. So whereas a XE or XB product is based around carbon and hydrogen, the XC is based around carbon and fluorine, and that creates an even higher bond energy at the molecular level, which increases thermal resistance and chemical resistance as well. And then we have the XF diaphragm that replaces 286. This is a Kevlar reinforced CSM material. It's a chlorosulfonated polyethylene. Used only on WFB products, okay? So it's used for fire isolation, hence why it's Kevlar reinforced. The other 3 products here are all reinforced with nylon fabric. That increases the stiffness of the material to help it withstand closure forces and pressures in service. But with the fire diaphragm, of course, we have to have that added fire retardation, which is why we have a Kevlar reinforced product offered in this bracket. Next slide, please, Ro. Okay, so here we talk a little bit more about the compression set improvement on this new XE product, okay? We've improved compression set by about 50%, but it doesn't mean the product is fit and forget. It doesn't mean it's maintenance free. It just means the propensity to continuously retorque this product is less. And resultantly, it improves leakage to atmosphere because of that. Okay, it's a replacement product for XA and 425. Next slide, please, Ro.
Yeah, thank you, John. So, as John correctly mentioned, the backing material or the rubber part of the diaphragm is very important in terms of material selection. Now, what we do is we put a PTFE face on these diaphragms, and unfortunately, you still get a level of permeation through the diaphragm, through the PTFE face. which is why it's important to have the correct backing material. So with regards to PE, which is a high performance EPDM diaphragm, this is very good for your concentrated acids and alkalis and chemicals such as nitric acid. Also very good in sodium hydroxide at high concentrations. And that replaces the old grade we used to call P2, which was a 214 slash 425, which is an EPM grade. Then we have the PB diaphragm, which is a high performance butyl diaphragm. And this is very good in services such as hydrochloric acid at 33%, caustic sodas, and this replaces the old P1 grade. Now, these two, as John mentioned, they are very highly interchangeable with each other. They can almost see the same processes as each other. So it is a lot of the time down to whether which diaphragm type is specified at site. But rest assured, both would usually work in those applications. But PB performs a little bit better in terms of gases, and PE performs slightly better than PB in terms of the chemical resistance required. Then coming to the PC diaphragm, which is the high performance chemical diaphragm. So the backup material here is the fluoroelastomer, or Viton as a trade name. And this is really good for applications where you're seeing high concentrations of sulfuric acid. So maybe a 98% sulfuric acid, and also acids at high temperatures. So that's where the difference comes in between PE, PB, and PC. The PC diaphragm can perform a little bit better at higher temperatures and higher concentrations of acids. Then we have the KE diaphragm. So as I mentioned, the K indicates it's a three-layer diaphragm. So you firstly have the PTFE face, you have a PVDF interlayer, and you have an EPDM backup. So this is more so for the aggressive chemicals such as bromine or some chlorinated solvents. And that's just to give that additional level of defense against permeation in those critical applications. And that replaces the old P7, which has the same thing, except for the backing material is no longer an EPM, is an EPDM, the extreme EPDM backup. Then we come to the premium range of diaphragm. It's the KC chlorine diaphragm. It is the Rolls Royce of diaphragms. And this diaphragm was made specifically for wet and dry chlorine applications in the chloralkali industry. And we considered this diaphragm because when you're working with aggressive chemicals such as chlorine, safety is the most important factor to anyone on site. If you get leakage of chlorine, you're in big trouble. So what we've done is we've taken this combination of diaphragm because the chlorine can permeate through the PTFE to a certain level. So we've added the PVDF interlayer, which John can explain in a little bit more detail as we go through the slides, but is a higher resistance to permeation due to the close links at a molecular level. Then we've added the Viton or FKM backup to this diaphragm. And that again is because it can perform at higher temperatures and is more defensive against these chemicals. And that is all put together with a titanium stud. So it's a very high-end product. You don't see a lot of competition offering such a diaphragm, and this diaphragm was created based on customer feedback. One of the customers advised that they needed something that will last a little bit longer than what was usually offered, a two-piece diaphragm. So this is being created specifically for that application, and we hope that this will give it a longer lifetime, but also perform to the level that ensures safety across the site. And once we go through the frequently asked questions, one of the questions are, how often should I change my diaphragm? If you have such a critical application like this, we aim that this will give you a 5-year life, but that is all dependent on what the cycling process is, the temperature, the concentration. There's a lot of variation that goes into this, which we can't put an exact number against this, but we know it'll perform better than some of the two-piece diaphragms which you've seen some customers using in this application. So it's still good to change a diaphragm as a preventative maintenance method, but we do believe that this is a solution to these applications. Then what we have here is a chart indicating the the corrosion or chemical resistance versus abrasion resistance. So if we just look at the elastomers first, all of the diaphragms with the first letter being X for extreme, you have the XB, which is a butyl, and the EPDM just above that. And as I mentioned before, there's very slight difference between the two, where EPDM can offer slightly better chemical resistance against certain applications. Then we have the XF diaphragm, which is the extreme fire diaphragm. We've put this on this chart just for completeness, and this is specifically for the WFB valves. But as you can see, it's got a good performance, and it's only manufactured in one size. That's a DN65. Then, when you come across, as John mentioned, is a different chemistry for the extreme chemical, the Viton diaphragm, which is why there's a big difference between the chemical resistance of the EPDM butyl and the Viton diaphragm. Then when we come to the PTFE, the high performance PTFE range, the EPDM and the butyl backup diaphragms, they perform considerably better than the extreme chemical diaphragm, but they have less flexibility, hence the less abrasion resistance that you can perform with in these diaphragms. Then another premium grade that we offer is the high performance chemical diaphragm. So this is the XC behind a PTFE facing. And again, this has an enhanced chemical resistance. Then we have the KE diaphragm, and that's our 3-layer EPDM backup diaphragm. And again, this is good for your chemical or highly aggressive chemical applications, which the other ones may not suit just due to the concentration or the temperature range it's being servicing in. And then finally, as I mentioned before, the highest chemical resistant diaphragm that we offer, the KC diaphragm, and you can see it's leaps and bounds above the rest in terms of the chemical resistance that it offers. But this is a very niche diaphragm. It's specific to these chlorine applications due to the specification of the parts that go into this diaphragm. And the major change we've made is the bag design that we now offer with this new range of diaphragms. So one of the things we considered when creating or designing these bags or the packaging for the diaphragms is how we can do our part to help the environment in terms of when you're disposing of these bags. Now, you may be ordering these diaphragms in the hundreds. Now you're disposing of 100 bags. We wanted to make sure that we're not adding to the carbon footprint. So these bags are recyclable, which is a huge plus in terms of what we're doing for the environment. It also has updated information about the range that we now offer, the extreme elastomer range and the high performance PTFE range. You also have some contact details at the bottom of the bag, telling you who to contact should you require further technical information or guidance. And all you need to do is send an email to that email address, and a member of our team will come back to you with the most appropriate response. We've then also included a QR scan code at the back of the bag. And this is more so for either yourselves, just to understand technically a little bit more about the diaphragms, but this scan code will take you directly to our website, where the section of the diaphragm valves are located, or the diaphragm, shall I say. And you can get more information in terms of what applications it might be good for, what the graph of the temperature and pressure is, what the codes are for reordering. There's a whole host of information available. And it might be useful for end users when their maintenance engineers are installing the diaphragms, just to double check, okay, this diaphragm is good for this application, or what's the torquing pressures or torquing forces that I need to apply to install this diaphragm and close it off. They also have some guidance on how to reorder the diaphragm. So when we ship out these bags with your diaphragm, there's also a printed section here which includes the grade of the diaphragm that you've ordered, and what the reorder code is. So there's no mistake made in ordering the wrong diaphragm. That's very clearly printed on the bag, and you can keep hold of that bag until they get back to the office and reorder the same. And another major benefit of these bags is the safety aspect. Now, a lot of you are familiar with our products, and you may have received a spare diaphragm in an older version of this bag. Now, when you're trying to open this bag, or a maintenance engineer is trying to open this bag, what you'll find is a very tough plastic material. So you either need to take a sharp object like a knife or a pair of scissors to open the bag, or you need to, hoist it open with your fingers. And to be honest with you, I mean, it's quite painful trying to do it just one bag, never mind, 10 or 100 bags. So what we've added to the bags now is a perforation. So perforation is a set of indentations within the bag. And once you apply some pressure or tear from this point here at the top, the bag tears open. And it's so simple to get your diaphragm out. And this will save the maintenance engineers, or even yourselves, because some of you are configuring valves at your sites before sending off to the customer. It will save you some time in terms of opening the bags, and also ensure that when you're using a sharp object, you do not cut yourself in the process, or you do not damage the diaphragm in the process, which will obviously have some implications in terms of the performance of the diaphragm. So we've considered a lot of factors when designing this bag, and hopefully you'll see the benefit of this if you haven't already. If you haven't, I suggest you order some diaphragms from us so you can get a bag and experiment with it. And finally, what we have here is our comparison table, so the rationalization table. And what's good to call out here, as John mentioned before, the first two in the old range, the EPM or the 425 or the EPDM and XA, have now been rationalized to one grade, and that's the XE diaphragm with enhanced compression set properties. And the remaining grades, as you can see, it's quite messy in terms of the codification of these diaphragms. So internally, we would call this a 425 or an XA or a 300. For you as our distributors and customers, you would reorder based on this code E2XAB1. So in order for us all to talk the same language, we've made all of the codes the same, internal or external. You now have the same code. So as I mentioned before, if you have a one-piece elastomer diaphragm, they are denoted with the first letter of X, and the second letter is the grade of material or the application. Same with the PTFE range, the high performance range. All of those start with a P and then the backup material. And then finally, we have the three-layer diaphragms, which is K. So there's no confusion as to if it's a one-layer, two-layer, or three-layer diaphragm. The first letter will very clearly tell you this. And also, the backup material is also used as a second letter for making up this code. So again, you will not get confused between an EPDM and a butyl. It's impossible because you're using E for EPDM or C for chemical. So that concludes the main part of the presentation, but what we'd like to do now is just move into some of the frequently asked questions that we have seen, which John will take you through, and hopefully we'll have some time left over to go through some of the good questions that we've had in the chat box throughout the presentation.
Okay, so the first question really is all about why is this important, and that's really the crux of why we're having this conversation today, is to make sure that the right diaphragms are used in the right applications. Incorrect material selection can lead to premature product failure, which ultimately can lead to breaches of safety, injury, accidents, product loss, etc. Even closure of plant, depending on what that typical failure is. So it's very important we get the products right. Ourselves, Saunders, it's very important that you guys as customers and distributors sell the right diaphragms into the right applications as well. If we have a incorrectly selected material, the chances are it will fail, and that can fail in a number of ways. It can leak to atmosphere, so it can leak out the sides and potentially hit somebody and injure them. It could leak into the top works, into the actuator, into the manual bonnet, which can then prevent correct operation of the valve. Or it could leak downstream, which could then cause processing problems. It could cause a dangerous environment for somebody else working further down the product line. If, for example, two incompatible chemicals were to meet and mix, that could lead to a catastrophic failure. So it's really important that we understand as much as possible about the customer's application, and we ask the right questions of the customer in terms of pressure, temperature, line media, etc., to allow us to spec a diaphragm to suit a particular application. Next slide, please, Ru. One of the biggest questions I face is, how long will my diaphragm last? If I have a set of conditions, how long will it last? And it's difficult to put a number on that because, as I'm sure you are aware, not only does diaphragm life change in terms of system to system, plant to plant, it can actually change between, say, two DN50 valves in the same process system. One DN50 valve can be operating 10 times a day, one could be operating once per year. So the chances of failure of that one operating at a high flex rate is increased compared to the one operating one time per year. So it's hard for us to give a clear answer on that. Of course, the temperature it operates at is also critical in terms of lifetime. If it's operating at high temperatures or under highly concentrated chemicals, that can cause premature failure, particularly if the material is not selected properly for the application. So it's very difficult for us to put a figure on that. And what you see on screen here are just some of the criteria that denote how long a valve lasts. In particular, size is quite interesting. Typically, smaller valves will last longer than larger valves, or diaphragms, I should say, would last longer. Smaller diaphragms last longer than larger diaphragms. And that's largely due to simple geometric stresses. A small diaphragm doesn't have to travel quite as far as a large diaphragm from the open to closed position, so resultantly the stresses are lower and premature failure is less likely to occur. One thing you'll see with our products is that on the bags in particular, it states the shelf life of the diaphragm. This is between 5 and 10 years, depending upon the grade of material being utilized. It's important that customers rotate their stocks to ensure that the oldest diaphragms are being used first, and that the diaphragm that is overaged doesn't get put into a line, and then again it could fail prematurely or unexpectedly because the polymer has degraded over time, sat on a shelf in storage. Next slide, please, Ro. So the biggest reason for failure that we see is overclosure and misuse of the diaphragms. I don't think I've ever really seen a diaphragm fail due to fatigue. Usually there's some other external influence happening that causes that diaphragm to fail prematurely. And what you guys will see as customers and distributors, you will receive diaphragms back that have failed, and those diaphragms contain evidence to allow us to almost forensically piece together what's happened to this product over its life cycle. That diaphragm will display evidence that suggests overclosure. It may suggest incorrect installation. It may suggest chemical attack or something from the line media causing failure. If you look at the images here on the bottom left-hand side of the screen, particularly the A-type product, which is on the right of those two physical diaphragms, what we can see from that diaphragm is, number one, there's a heavy compressor imprint on the back of the product, which suggests the valve has been overclosing. Now, what I've seen, particularly in the field, and I'm sure you guys will have seen the same, people will walk past valves and they will tend to give the hand wheel a little close just to make sure the valve is still sealing. But all the time they do this, they're pushing that diaphragm against the weir and causing premature failure. Also, what we tend to see happens is customers overspecify actuators for the line media. So they might have an actuator that can close off 16 bar, but they run the valve at maybe 1 or 2 bar. And again, all that does is just overclose the diaphragm, make it work harder, push it harder against the weir, and cause premature failure. So it's about sizing the valve correctly as well, as much as anything else. Also on that PTFE diaphragm you see on screen here, you notice the cross pin is parallel to the weir form. Now, that should be perpendicular or 90 degrees to the weir to allow it to sit correctly in the top works. Now, what's likely to happen here is the customer or the end user has not pushed that diaphragm into the top works far enough and rotated it, and instead they've caused that stud to turn 90 degrees inside the PTFE. Now, this product, of course, will not hold itself within the compressor of the top works correctly, and it will fall out either immediately or over time. And what can happen then is that the valve can still open partially because it's not connected to the actuator. The line media can still push against the diaphragm and open it up, partially indicating that the valve is operating correctly. But what is actually happening is the valve is not opening fully. And when the valve does close, it will crunch that stud against the compressor, damaging the PTFE face and potentially damaging the valve body as well, especially over repeated use. That's particularly important for unlined products which are polished to allow for a good seal with PTFE, and also for lined products, particularly plastic lined, which can have catastrophic deformation as a result of this. It can essentially gouge the line in, which then it causes a leakage path. So not only is the diaphragm now damaged, also your body is damaged, and the whole thing becomes a much more costly replacement for the end user, all because something was not installed correctly. The IOM and the bag also contain details of how to install these valves correctly, particularly around centralization, which is the image on the bottom right here. What we want the diaphragm to do is we want it to be centralized as close as possible about the weir form. Now that creates an optimum situation where when the valve is inverted, the diaphragm is not overstretched and elongated beyond its sort of usable requirements, which can result in premature failure. So for that, we recommend that the valve is closed and 3/4 torque is applied in a cross pattern, then opened and the final torque applied. And if you follow those instructions as per the IOM or as per the bag, you will get a valve that is properly centralized about the weir form, and it is optimized for use to prolong its life as far as possible. The next slide, please, Ro. So Saunders have 3 main fitment types of diaphragm, or 3 fitment types absolutely for diaphragms. One is the button fixing on the left-hand side here, and that really only relates to the fractional valves, the DN8 through to DN20 products. And it's a function, again, of history and legacy. So in years gone by, Saunders only supplied products with a button fixing, and in order to keep servicing customers with top works that suit a button fixing, we continue to supply diaphragms with that attachment method. There are flaws to that method in that it only attaches under friction, and resultantly a vacuum in the line could cause that diaphragm to pull out of the compressor and disengage itself. So we do prefer to offer screw-type connections, which you see in the middle slide here, but we still maintain offering the button fixing because it's sometimes not cost-effective or feasible for customers to change all of their top works to a screw thread attachment type because they may have thousands of valves on site. Some may not be accessible. So it's something we offer as legacy product. Now the screw thread and the bayonet attachment types, bayonet for PTFE, screw thread for rubber, as I said earlier, that creates a much better mechanical connection between the compressor, which prevents pull-out under vacuum. So it's a much more robust connection system that we do prefer to offer for new valve assemblies. Next slide, please, Ro. And in relation to the KE, and particularly the KC diaphragm, Roy has touched a lot on permeation resistance. So I thought it would be pertinent just to discuss what permeation is a little bit in the most basic form. So permeation is the transition of a gas from one side of a product to the other. Now what happens is that small molecules in the lime media can travel through the diaphragm and into the topworks or into the atmosphere by this process called permeation. PTFE as a molecular construction contains carbon atoms all in a line together. Okay, so if you imagine a row of carbon atoms, and wrapped around the carbon atoms in a spiral form to protect them is fluorine atoms. Now fluorine is a very, very small molecule, so it protects the carbon very well from chemical attack. That's why PTFE and fluoropolymers have such a high chemical resistance. Larger molecules physically can't get to the carbon backbone to attack it and resultantly cause failure. But what can happen with smaller molecules than fluorine, which tend to be what we call the halogens in the chemical world? That's things like chlorine, bromine, iodine. Those smaller molecules can actually move through the PTFE because they fit between the gaps within the molecular structure. So how the KC particularly helps resist permeation is you've basically got a triple layer of protection. You've got the PTFE interlayer, sorry, the PTFE face-in, the PVDF interlayer, and the Viton or FKM back-in. So by having all three of those, it makes a real difficult path, what tends to be termed a tortuous path, for those molecules to come out the other side, and they tend to lose energy and just dissipate or disappear in that process. So what we found at Saunders, we did some testing on chlorine at 80 degrees, which is kind of a very typical temperature, very typical line media. By using the three-layer diaphragm, we reduced the permeation amounts by around 80%. So that's very pertinent, very important for the customers because they don't want to have this gas buildup either in their valves or around their valves. It can cause a safety issue. So we want to contain all of that media into the valve, sealed off, away from where people are walking or working. So the KC diaphragm is not, by any means a general diaphragm for general use. It's a very niche product, but it's very, very good and very, very well designed for use in heavy and fine chemical processing plants, especially where the halogens are being used predominantly to limit permeation. Okay, next slide, please, Ro.
That's great. Thank you, John. Thank you very much for your technical expertise on the matter. So that's all we've covered today on the webinar. So apologies, we've run over time slightly. And we've had a lot of good questions come into the chat box, which unfortunately we're not able to answer right now. But what we'll aim to do is follow up with a questionnaire, so we can get your feedback on how you believe the webinar went, how you felt it went. And there'll be a list of questions on there. So if you feel that there was a particular section which you want to know more about, we can certainly come back to you with a response on that, as well as the questions that have been asked. We will aim to respond to those questions. If you do have any questions, please email the email address shown on the screen, idvexperts@cranecpe.com, and one of our members of the team will come back to you with the correct response. And please follow our LinkedIn page, because we're quite active on LinkedIn and we're providing a lot of updates through LinkedIn. But again, as I mentioned, please email us anytime you come into any trouble or you need some guidance on some technical recommendations. We'll be more than happy to help. So I really appreciate everyone joining this webinar today and taking time out of your busy schedules to learn more about our product range. And we hope to hear from you soon. So thank you very much for attending. Take care.
Okay, thank you.
Thank you, Rohan.
Bye.
वेदांत बाण खाली नको करू जास्त.